Okay, this is the fourth video where I'm actually going to this is the midterm review, and actually going to cover. I'm going to go over these two problem sets here. It's just basically the first page of the. They look just like the first page of the example midterm here, and so it's just a bunch of 14 more of those problems. So I'm going to go over those so we can see, so we can get some more practice. I've actually combined them into one document. This is the first one, and this is the second one. And so I'm just going to go through these now. Okay. Let me put this down. Okay. It's the same set of charts and graphs and measures and tables and so on. You are employed as a manager of a new Shell service station, and you have the following 7 situations in which you need to use your expertise for statistics. For each of the questions, we want to see what determine the most appropriate table, chart, or diagram, or plot, or whatever that fits the situation. So, number 1. In an effort to improve the quality of engine care, 50 automobile engines were tested for the cause of the problem with the engine. 12 of them had cracked blocks, 3 had leaky radiators, 20 had oil leaks, 6 had faulty cylinders, and 9 had ignition problems. If you add these up, you get 50. So we have categorical data. We've got 50 automobiles. Each one of them falls in one of these 5 categories. 1, 2, 3, 4, 5 categories. And we want to improve the quality, so we'd like a chart that will not only help us identify what the worst offenders are, but also it'll also lead us perhaps to the best, easiest solution to help improve the quality of these engines. So this is a single categorical data, and if we look at our study guide here, we see a single categorical. What we want a chart. The A chart is for if we're taking. That's for quality control, and we take a series of samples over time. So if that's not it, we just have one sample of 50. G is a bar chart. That's useful. It allows us to see differences between the different categories. It doesn't order them though, like the Pareto does. H would be is a Pareto. That I think is the one that we want to use because the first bar will be the worst offending, and we'll also see the percent coverage across the top too. So that's very helpful. And then I is a pie chart. That's good to see a proportion of for that particular category as a proportion of the whole. And I think the Pareto is still the best one to use. Okay, what's next? Number 2, you are looking at the time to complete a car wash, and you want to be able to make statements about 80% of the car washes take less than 5 minutes. So which plot or graph? Well, in this case, it's numerical data and a cumulative percentage polygon, which is an OGIF, will give us a curve which tells us as x-axis will be the time, and as we increase in time, what is we see the percentage increase, and we'll be able to look directly to see where 80% is, and we will be able to see what that time is. So if we go here, it's numerical data, one numerical, and for charts and graphs we can use the histogram. E is a polygon. F is a cumulative percentage polygon. So that's the best one for that case. A tire manufacturer routinely samples a brand of tires and records the tread depth. So this is over time. He randomly picks 5 tires every 15 minutes throughout the day. So here it's a quality thing and it's a process, and we want to be making sure that the process is in control and where it is. And so, and it's actually numerical data. It's not pass or fail. We're actually measuring tread depth. So that narrows it down pretty much. One numerica. It's going to be a range and means chart, which you can confirm back here, which would be this one here, range and means charts. The next one is you wish to compare the variability in times to service compact cars, full-size cars, and luxury cars, which are concerned at the fact that it takes much longer to service luxury cars. Okay, so it's a variability question. We've got 3 categories, and compact, full, and luxury, and we're comparing the variability in time. So that means we have a bunch of data on times to service in each of these 3 categories, and we want to compare the variability. We want to compare how much the times vary. The fact that luxury cars take a whole lot longer means you can't really compare them against each other. You need to compare them against themselves. So coefficient of variation is really the one that we want to look at there. Okay, so 1C, 1N. Usually with that, it's 1C, 1N. You do the same as above, but one for each category. So for each category, you can look at the coefficient of variance, the coefficient of variation, and we'll get percentages, simple percentages, and we'll be able to see which category has the highest variance. Okay, what's next? Number 5. You sell 4 different grades of gasoline, and you wish to present a visual display of last month's worth of daily sales volume. From the display, you wish to be able to easily compare central tendency, variability, and shape. Okay, so you're again, it's 4 different categories and sales for each category, and we want to look at shape. We want to look at central tendency. We want to look at variability. It really sounds like a box plot would be best for us for this, because if you recall, for a box plot, you get to see the median, you get to see the interquartile ranges, you get to see the range, and where those quartile lines are. We also can get an idea of skewness, and a couple of different ways we can look at variability. So the answer is J. So we would create a single graph with these 4 different box plots on the same page, and we could see the differences between each other. Okay, the 5th one is a tire manufacturer randomly samples 30 tires at the end of each shift to see which ones are defective. Okay, so this is a proportional chart. We're looking at defects, single categorical data. It's over time, and so it's a process. We want to keep tabs on make sure the process remains in control. It's just pass or no pass. So P chart, proportional chart, is the best one for that. And number 7 here is you wish to examine data on whether or not cars have complaints about service depending on the day of the week. So we've got it's 2 categories. We've got complaining customers and non-complaining customers, and we've got, I guess, it's probably 6 days of the week. They're probably not open on Sunday. So we've got 2 categories, 6 days. Each category is a day, and a customer complaining or not complaining is the second. So that's 2 categories, which is a cross tabulation. We can confirm that here. All right. So that's it for set number 1. I'm gonna I think I'll end this video and start set number 2 with the next video. Thanks very much for watching.